Close your eyes and picture the beginning of the universe. You already know what the movie looks like. Black, empty space. A single brilliant point hanging in the darkness. Then a detonation, light and matter hurled outward into the void, debris rushing away from a center like shrapnel from a grenade. Every schoolbook prints a version of that picture. Half the documentaries ever made open with it. And it's wrong. Not slightly wrong, not simplified for television. Wrong in every frame, starting with the black empty space, which is the one thing the Big Bang absolutely did not have to explode into. Here's the corrected version up front. The Big Bang wasn't an explosion in space. It was the expansion of space itself. The bang didn't happen at a point, it happened at every point at once. And there's no center to it, no blast site, no debris field, and no outside. And if you want to visit the place where it occurred, you don't need a spaceship. It happened precisely where your kitchen now stands. Also at the North Pole, also in the Andromeda Galaxy, also in the emptiest gap between galaxy clusters, because when every distance in the cosmos was zero, every place was the same place. The whole universe was the fireball. The fireball is the one thing you cannot stand outside of. That claim sounds like philosophy, so let's treat it like evidence. Ask a simple question: what would an actual explosion leave behind? Debris with a middle. Fragments flying through space, fastest at the front, thinning out with distance, and if you rewound their paths, they'd all converge on one spot, the crime scene. An explosion picks a location, and it picks a direction for every fragment. That's what bombs do. Now look at what the universe actually shows us. In 1929, Edwin Hubble published measurements showing that nearly every galaxy recedes from us, with speed proportional to distance. At first glance, that sounds like we're the crime scene, the center everything flees. But run the same numbers from any other galaxy, and you get the identical picture. Observers in Andromeda see everyone receding from Andromeda. There is no privileged middle. Every vantage point looks like the center, which is exactly what you'd expect if no true center exists, and exactly what you would not expect from a bomb. Then there's the sky itself. The oldest light in the universe, the cosmic microwave background, arrives from every direction at almost exactly the same temperature, 2.725 degrees above absolute zero, matching to about 1 part in 100,000 across the entire sky, as mapped by the COBE and Planck satellite missions. Explosions don't do that. Shrapnel is lumpy and directional. It has a hot side, a source you can point back toward. The universe has no such direction. Wherever you look, the glow is the same, because everywhere was once the inside of the same furnace. In the 1960s, the physicist Robert Dicke's group at Princeton predicted this relic glow ought to exist, and in 1965, 2 radio engineers at Bell Labs, Arno Penzias and Robert Wilson, found it by accident in a horn-shaped antenna in New Jersey, a discovery that earned them the Nobel Prize. The signal that annoyed them as noise was the entire sky, still faintly warm from the beginning. So where did the explosion picture come from? Partly from the name, and the name was written by the theory's biggest enemy. On the 28th of March, 1949, the Cambridge astronomer Fred Hoyle gave a talk on BBC Radio defending his own rival idea, a steady-state universe with no beginning. To describe the theory he opposed, he reached for the most cartoonish phrase he could find, the idea that everything was created in one big bang at some moment in the remote past. The mockery outlived the mocker. Hoyle's steady-state model was eventually buried by the evidence, but his insult stuck as the brand name, and it smuggled a bomb into everyone's imagination. The man who actually proposed the idea had framed it very differently. In May 1931, the Belgian priest and physicist Georges Lemaitre published a short note in the journal Nature. The universe, he suggested, began as what he called a primeval atom, a single quantum whose decay set the expansion going. Lemaitre had already worked out the expanding universe mathematics in 1927, 2 years before Hubble's measurements, which is why, in 2018, astronomers voted to rename the expansion law the Hubble-Lemaitre law. The beginning, as Lemaitre saw it, wasn't a bomb in a void. It was space and time themselves starting to stretch. Stretch how? The classic prop is a balloon with galaxies drawn on its skin. Inflate it, and every dot moves away from every other dot, yet none of them is the center of the rubber. It's a genuinely useful picture, and it fails in 2 instructive ways, so let's use it honestly. First, a balloon inflates into the room around it, and the universe requires no room. The stretching is internal. More distance appears between things without the whole needing anywhere to grow into. Second, the drawn galaxies stretch with the rubber, and real galaxies don't. Gravity binds them. You aren't expanding, your galaxy isn't expanding, only the vast distances between gravitationally separate things grow. What expansion really does is quieter and stranger than any balloon. It manufactures new distance everywhere, continuously. And it stretches light along with it. A light wave crossing growing space gets pulled longer and redder as it travels. That's the redshift Hubble measured, and it's why the beginning's blinding glow now whispers in microwaves. The waves have been lengthening for most of the age of the universe. Follow the logic far enough out, and it produces something an explosion never could. Galaxies far enough away recede faster than the speed of light. That isn't a scandal, and it doesn't break Einstein's rules, because nothing is moving through space at that speed. The galaxies are nearly at rest in their own neighborhoods. The space between us and them is doing the growing. Distant regions genuinely slip beyond any signal we could ever send or receive. What surrounds us isn't the edge of the debris, it's a horizon of visibility, and beyond it, the universe simply continues, quite possibly without end. Which forces the real question into the open. If it wasn't an explosion, what actually happened? Strip away the cartoon, and the theory says this. Around 13.8 billion years ago, by the Planck mission's measurement, everything we can now see was compressed into a state hotter and denser than anything a laboratory has ever approached, and it was that way everywhere at once, whether everywhere was already infinite or merely enormous. Space expanded, the temperature fell, and the aftermath assembled itself over billions of years into atoms, galaxies, and eventually astronomers. Notice what that account never includes: an ignition. The Big Bang Theory is a description of the aftermath, a history of cooling, and it's magnificently well tested. The first instant itself is outside it. Trace the equations back toward time zero, and general relativity predicts infinite density and then stops cooperating, which most physicists read as the theory confessing its limits rather than describing a real object. Cosmologists have a leading candidate for what set the hot expansion off, a proposed burst of stupendously fast stretching called inflation, and it makes predictions that survive every test so far. But it remains a hypothesis about the trigger, not a settled fact, and whether anything came before, or whether before even means something there, stays honestly open. So here's the trade I'm offering. Give up the bomb in the darkness. It was never the theory anyway. It was a rival's joke that got printed on the box. In its place, take the version the evidence describes, because it's stranger and, I'd argue, grander. There was no dark, waiting emptiness. There was no fuse and no center. There was a moment when every point of an endless ocean of space, including the point where you're sitting now, blazed hotter than the heart of any star. And then the whole ocean began to widen, and it has been widening and cooling for 13.8 billion years, into starlight, into planets, into the faint microwave hum that still arrives from every direction of the sky. You've never seen the Big Bang from the outside, and you never will, for the best possible reason. There is no outside. You're not descended from the explosion. You're still inside the event, watching it cool.